Hello there. Today we'll be doing find median of data stream. This is a hard problem in heaps and queues, number 139 in our Neetcode 150. All right. I have this completed here. I created a max heap and a min heap, and I provided the median finder here. Okay. This code does not work. Output limit exceeded, but it does work if I do not implement the max heap and the min heap. Yeah, weird Neetcode stuff. But I do think that this particular problem is neater with these functions and reduces the possibility of error, but it does not pass. So why are we doing this? What's going on here? Why do we need heaps? So first of all, what we're doing here is let's reset this, or yeah, let's reset it. So what's going on here is that we had a O of n runtime for add and a O of 1 time for find median. By adding each item to the median and finding it by splitting the add numbers in half, and if it's even, just get the next one and add them together and divide by 2. But it takes O of n time to add items into the add nums. A way to speed that up is to use 2 heaps and split it into 2. That way we can insert items at the log n because of the tree format of a heap. And with a heap, we can use a max heap for the small numbers on the left side, and that will be the left number, and the min heap for the big numbers, for large numbers, and then we can get those two numbers if it's even the number of items. If it's an odd number of items, where either the small side or greater side has more items, then we'll take that. So take odds based on greater heap if both heaps are equal. Take both and divide by 2. To add nums, we will use 2 heaps, min heap for large and max heap for smalls, and this will split the list in 2 if item in min heap in a small greater than large, move to large. If more items in small, move to large. If more items in large, move to small. And that's it. And then we make sure that both lists are equal every time we add a number. Every time we add a number, it's either going to be too big and we add it to a larger side, and if it's too many goes into the larger side, we move one back to the smaller side. If there are too many on the smaller side, we move one back to the larger side. That's pretty much the code, and we keep everything in the middle. This is pretty creative. I think if I've never seen the solution, I don't think I would be able to do it. And the only way to do it is to do it in a less neat way. And here we go. So small, large equals one empty array and another empty array. So we need to heap q, heap push self.small, right? This is self.small, and we're going to put the num in, right? So what we're going to do is we're using 2 heaps. So if self.small and self.large, if this is true, and self dot small, the first item. Of course, we have to multiply it by -1. And this is the problem with this. Oh, right, we have to multiply this by -1. This is annoying as heck. But it is what it is. So is greater than self dot large. If that is the case, if these both exist and this smaller item is greater than the larger item, we're gonna move it. So bar value equals what? -1 times heap q dot heap pop self dot small. Right, and we're gonna insert into the large one now. So heap q dot heap push large self dot large, and we're gonna insert it the value. Great. So next bit, if self dot small, this is the length of this item, is greater than the length of self dot large plus 1, because we can have a buffer of a single item because of the oddness, but if we have two items that are different, then we need to move the item from the small to the large. So val equals -1 times heap q heap pop self dot small and heap q dot heap push self dot large at var. Otherwise, if length of self dot large is greater than the length of self dot small plus 1, val equals heap q dot heap pop self dot large and heap q dot heap push self dot small and -1 times val. Alright, I think that we're done with all our add nums, and now we need to do our odd case and then do the even case. So if length of self dot small is greater than length of self dot large, that means we have an odd and we have more than the small, so we're going to return -1 times self dot small at 0. If length self large is greater than length of self small, return self large 0. Otherwise, we'll just return both. So -1 times self small 0 plus self large 0, and then we'll divide it by 2. Of course, this needs to be in parentheses, and we return. And I think that should be it with all the comments. I don't think I'm missing anything. This looks pretty okay to me. Let's run it. Looks good. Let's submit. Wow, it worked. I hope you've learned something today. This is a very interesting and fun technique of how to find the median in a data stream and reduce the add num to a log n time rather than a O of n time. And we learned something today. Yeah, and that's great. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.